Hello everyone, welcome to my training session on strategy design pattern. It's very important to implement the correct design pattern in your code when you are developing any software application, big or small. Strategy design pattern is one of the most important and frequently used design pattern in software applications. Although it's frequently used, but sometimes programmers feel difficult to choose the correct design pattern. For example, in the coming slide, I will demonstrate one example where you may think of implementing factory design pattern also. So here is in this session, I will explain what a strategy design pattern is from its definition and how to identify where to use a strategy design pattern, and then I will move to a detailed code example. If I go with the definition of a strategy design pattern, strategy encapsulates the algorithm. That means it hides the algorithm implementation from the outside. Here, outside means the client who is going to consume our business library. Strategy basically exposes only the interface, not implementation to the client, and that way client doesn't know how the actual code or algorithm is implemented, and thus it allows client to change the algorithm. If you see this diagram on the slide, here strategy uses the interface, which can point to any concrete strategy like concrete strategy A, B, or C. Here in this example, context is the class who is responsible to choose the right strategy. The picture on this slide is from the example given on Gang of Four website. Here the client has an array and wants the sorted array. Sorting can be done by any sorting algorithm like bubble sort or quick sort, etc. And in this diagram, like sorting algorithm A, sorting algorithm B. If we implement this sorting logic or the algorithm at client without using a strategy pattern, it will be against the open-closed principle. Because tomorrow if we introduce another sorting algorithm, we have to modify the client code, which is against the open-closed principle. Open-closed design principle says our design and classes should be open for extension and closed for any modification. And if we are introducing any sorting algorithm, new sorting algorithm, we have to modify the client code. So here in this example, we use a strategy pattern. And when we use a strategy pattern, our algorithm is hidden from the client. And client will use something very generalized code like sort manager dot sort. And he can pass the array parameter to be sorted and the algorithm type A or B. So this is a very generalized code at the client, and he can interchange the algorithm from A to B, depends on the requirement. So this is one very good example of using the strategy pattern. So it's very important to identify the situations, identify the scenarios where you have to use the strategy design pattern. In this example, I can implement factory design pattern too, where factory can return two sorting utility classes representing each sorting algorithm. But that would be an incorrect implementation. Factory is a creational design pattern while strategy is a behavioral design pattern. So to identify which design pattern we should use, we should raise a question how. How our algorithm is implemented, that is behavior. And we have just a difference in algorithm implementation. So whenever you see business scenarios where you have similar objects with similar functionality, but actual different code to implement this logic, we are most likely to use a strategy pattern. Here in this slide, I want to demonstrate one very good real life example using a strategy pattern. So I want to create one email business library. that will be used to send email notifications for business and for exception or for any other thing. And I have used this library in many of my projects, many of my applications. And in this library, each type of email class, business email or exception email, if you see, they have similar properties like SMTP, to, from, subject, etc. But the how the email body is constructed is different in each email type. That is, the algorithm or the code logic to create the email body is different. So we have two classes, business email strategy. We have another class, exception email strategy. We use strategy pattern. We hide the algorithm from the client, and at the client we would use something like email manager send email, and we can pass what type of strategy we want to use, business or exception, and we can pass another parameter to construct the email body maker. So this is a very good example of using a strategy pattern. Let's move to the actual code implementation for this. Let's demonstrate this email business notification library code using a strategy pattern in Visual Studio. Here I have opened this solution. This is the client code. Client wants to send the email notification of type business, of type exception. Here, if I implement this sending email code here, it will be against the open closed principle. So here I am using the strategy pattern, and at the client we have very generalized code, email manager send email. We pass the parameter to inform it to use business email or to use exception email, and one parameter email body maker to construct the each actual email body. So here I am using a strategy pattern. To implement this strategy pattern, first of all, we have to define one interface, iEmail strategy. This is the interface for concrete strategy to implement. We will have similar properties from to SMTP and email body, and we will have one method, create email body, that represents the code logic or algorithm to be implemented differently in different email strategy classes. We have email business notification strategy class, which is implementing this interface iEmail strategy. We have another email exception notification strategy class, which is implementing this iEmail strategy interface. And the create email body method, which has the algorithm implementation, is implemented differently in both the classes, in both these strategy classes. The other classes in this code are kind of helper classes. We have email manager class, which is a context class which is used by client to choose the required strategy. Here we have a general method called send email, which accept two parameters. One is email type and one is email body maker. Email type is helping to create the actual strategy. Email type business, then email business notification strategy. Email type exception, then email exception notification strategy. This strategy is pointing to the iEmail strategy interface. And we are passing this object for further processing. So when we come to the client, we have very simple code, email manager send email. And in these both the lines, email manager send email here and here, you can see we are interchanging the algorithm implementation. So at the client, we are hiding the algorithm. We are using a strategy pattern. This is one very good example. The source code of this example, this demonstration, I have checked into the GitHub, and the link is given in the below description.